Hello friends, welcome to my first video. The big question is, can we do 3D meshes, 3D models from 2D images? Hopefully this video will show you how, and you can create any mesh that you can imagine. I prepared a simple workflow that will guide us through the process of using images to generate 3D meshes. First, we have to obtain some kind of a reference image, be that a photograph you took, an image you downloaded off the internet, of course respecting the copyrights, or something that you generated via an AI image generator such as Stable Diffusion or Midjourney or any of those. Once we have this image, then we can generate via Trellis, which is a standalone software that we can generate the 3D meshes. Once we save the output from Trellis, we need to convert it into a format that is going to be possible to import it into DAZ Studio or Poser. I picked OBJ, however, you can use, I believe, FBX format. And then finally, we import this converted mesh into DAZ Studio, and of course we can use it for whatever rendering or scene that we had in mind in the first place. However, there are a couple of simple steps that we have to go through, and one of them is to install Trellis, this software by Microsoft Research that's freely available open source on the internet, to install it locally or on your computer. I have to keep in mind though that there is a online version of Trellis. I'm going to leave a link in the description below. However, in my experience, it is very limited. It is free, of course, but it's very limited in its capabilities of how much it can do, in a sense that you have to wait for a GPU to be available. And in 9 out of 10 cases that I've tried, it actually comes up with an error without generating a model. So try it if you want, but I'm including in this tutorial a way to install Trellis locally on your computer so you can generate any model without any restriction that the online Trellis installation poses in whatever form it is at this point in time. But first things first, let's install Trellis on our local machine. So in a new browser, follow the link that's in the description of this video to download Trellis's self or standalone installation from GitHub. We will need to get the file that's got a weird name. You need an NVIDIA GPU with at least 8 gigabytes of VRAM. I presume at this point in time, most of us have it. We're downloading a zip file from the bottom of the page, and then we run either rungradio.bat or rungradio fp16 for a GPU that has less than 8 gigabytes of RAM. So we downloaded the file, and then we're going to, I've created a new directory in which I'm going to extract it. Keep in mind the extraction process. I mean, it's a standalone installation. It has its own Python interpreter and all the needed libraries. So it will take some time, couple of minutes in my case. I cut out most of it so you don't have to watch it, but keep in mind it will take a couple of minutes to download it. Once we downloaded it, we browse to the directory where we installed it, and we're going to select one of the options, either, I guess, in Gradio, or if you have a web interface, or you can run it as an API. We're not going to do it in the API, but we're going to run it within Gradio to run it as a sort of a web interface like we traditionally used to do it for all sorts of web apps, including Stable Diffusion. So again, it will take some time to install all the libraries, probably a couple of minutes, quite a few gigabytes. It is going to take some time. So it downloads models that it needs, And once we're done that, then we're going to start by double clicking on the run Gradio, in this case FP16 file. We wait yet again. We have to wait a couple of minutes for the server to start up. I mean, I'm running this on a computer that's a fairly average, a card with 8 gigabytes and 10 gigabytes of VRAM. It's an AMD 5950X CPU. So it's something that I guess most of us have at home. We wait for this whole interface to load up. It has an error message, but about this Triton, just forget it. Once we get to this screen, it's giving a URL, a web page on your local computer. And that's pretty much it for installing Trellis on your local computer. And now let's switch over to Stable Diffusion to generate the images that we're going to use to generate later our 3D meshes. So the first step in our process of generating a 3D mesh would be actually to have an image or a photo of what we're trying to generate as a 3D model. Now the source of the the source of the image could be anything. It could be a photo you take or something off the web given the proper copyright. Or in this case, I'm going to use Stable Diffusion and AI image generator to generate the initial image that then we are going to use in Trellis to generate the 3D mesh. So this version of Stable Diffusion is hosted on my computer, but by all means use any image generator you want, be that Stable Diffusion or DALL-E or Midjourney or anything else that you're using or you have access to. It doesn't really matter. Now, a couple of things we have to keep in mind with the image. So let's try to generate an image of a Viking helmet. So giving the prompt Viking helmet, I'm using Wildcard XL Turbo SD model, but again, use whatever style you prefer in the image generator. I'm using all I believe the default parameters. However, being an XL model, I'm going to change it to 1024. I believe these models were trained on 1K images, so I'm going to change that and perhaps add the high resolution fix with say 1.2 upscaling, but leave everything the same. So going back to the prompt, for this test, I'm just going to use a Viking helmet, click on generate, and it shouldn't take that long to come back with an image, and we will see what we have. So as it is, we indeed have let's assume in this AI hallucination that it is a Viking helmet. However, we have a slight issue that we will see later on. Where did my image go? Oh, out of memory. So let's go back to 512 and then just upscale it. Sorry for the slight little interruption, but I'm trying to show the process on a relatively common graphics card, and even in these days, you run out of memory on it if you're trying to do something big. Nevertheless, we ended up with an image, and as you see, we have a slight problem. One, that it is on the actual person, which is not what we want. Also, as you see, these horns are cropped, and we have a background. So let's try to rectify it. So a Viking helmet on a black background. Let's see what we come up with this. And right away, you'll see from this relatively coarse rendering that there's nobody in the helmet, and it is on a black background. Now, in a few moments, once we start using Trellis, we will see why we want nobody in a helmet, in this case, and also why we want a black, or it could be white, yellow, whatever uniform background. We'll see that in a moment. Now, one thing that you have to note right away is that we might have, or chances are we do have a problem later on when we're trying to use the generated 3D mesh from this process, and that would be the lighting. So in this case, you see that there's some specular highlight on the horns at the, I guess, forehead area of the helmet, and even some side lighting. Now, unfortunately, this lighting is going to be baked into the 3D model. So these highlights and shadow areas are going to be part of the texture. Now, that may or may not be an issue with your using this in DAZ Studio or Poser or any other 3D package. If you're careful with matching the lighting on this object with the light in the scene. There are more advanced ways of get rid of this light. It's called delighting, but that's way beyond this tutorial. But keep in mind that we want the object that we're trying to generate the 3D mesh or 3D model of to be within the scene, so there are no parts missing. It is over a uniform background, so the 3D mesh generation doesn't have to fight or eliminate the background, although it has some facilities to remove the background we will see in a moment. But let's start with the best image as possible. So now I'm going to generate, let's make another 7 images. And I'm going to start it off, and once it's done, then we're going to switch over to Trellis 3D or Trellis and try to generate the 3D models. So let's enjoy for a moment what kind of weird and fancy Viking helmets the hallucination of the AI will give us, but hey, it's part of the fun. So see you in a moment as soon as this completes in Trellis. So you see this one, in this case, there is somebody's beard and some kind of a weird horn and all sorts of things. But let's have a couple of images to work with, and then we'll see what we can do in the 3D mesh generator. So see you there in a moment. So welcome back. So we generated all the images that we want of these Viking helmets. And let's start up Trellis. So you go to the install folder, and in my case, I believe I'm going to run the run Gradio. So double click on that. It opens up a command window, and it will take its time. So while Trellis is loading, let's look at some of these images that were generated with Stable Diffusion. So let's look at the first one. We have a whole image, whole helmet on a blackish background, nice detail, so this should yield a good model. Next one, similar, a decent background, it should be okay. Next one, the tips of the horns are cropped off, but probably it's salvageable. Same with this one, nice scroll work, detail. Another one, looks pretty good. Yet another one. In this case, I changed it to a yellow background. It doesn't have to be black, as long as there is a good contrast, a good delineation between the subject that you're trying to make the 3D model of and the background. So it's not within a scene, no disturbing elements. It's a clear cut of what's important and what's not. And let's look at further ones, what we have in this little set. So all of these, you see that they should be viable models. So it looks like Trellis started. So in a command prompt, you get to the location where it's giving you the web service, the web page that you have to open. So in Windows, you hold down the control key and you click on it. It says control click, and it will open up a new web page with Trellis's interface. So Trellis's interface, before we start generating any images, let's look at what we have. We're going to be using the single image version because we have only one image of the object that we're trying to generate the 3D mesh of. In case you have a real life object that you took photos of from multiple angles, it would be possible for go with the workflow that uses multiple images. However, for this short tutorial, it's going to be single image. So this is where we're going to drag and drop one of the images of the helmets that we generated in Stable Diffusion. Now, as the instructions specify, the trellis itself will try to remove the background. Now, in most cases, it will work fine. However, if our object has a lot of dark areas or a lot of color tones that can be found in a background as well, then the automatic method in Trellis will remove part of the object, and probably that's not what we want. So going back to the idea back in Stable Diffusion that let's create the best image to start with that will help our 3D mesh generator, 3D model generator. Hence, a nice solid colored background, be that black, yellow, or whatever suits the particular object that you're trying to model. Now, a couple of settings. If you open this little triangle at the generation settings, very similar to what we have for generators that create, or the ones that created these images of the helmets, we have the guidance strengths. This would be very similar to the CFG in Stable Diffusion, a parameter. How many steps it will take within this 3D AI model, and similar for the second stage. For the time being, I'm going to leave these at their default values. However, for increasing the sampling steps, it will take perhaps longer. It could yield better results. Similar for the guidance strength, I believe higher the guidance strength, the more it's trying to create a 3D model of what it sees on the image that we are going to supply it. We're going to leave the stochastic method for the multi-image since we're not really using it, so it's not an issue. Now, so the first step would be, let's pick the first helmet. I'm just going to drag it over and see that there is a little bit of processing time. As it's claiming, it is trying to remove the background from the object. Now, it doesn't really know what the object is and what the background is. It does a decent job, but going back to what I said earlier, if we can help to create images that have a clear definition of what the object is versus background, the better. So that would be the first step. You drag the image. Then you can click on the generate button once and you will see in the upper right this little window, something is going on. It says processing, and also in the command prompt, you see some numbers are changing. It's doing something. So give it a time, whatever number it claims in how many seconds. It may or may not reflect reality, but let it do its work. And once it's done with this stage, it will create a small animation that auto plays. On the left side, it gives sort of rotating around the object of what it saw in its AI hallucination. And on the right side, it's giving you a quasi-normal map. But at the end, you will not get a normal map. Anyhow, so once you see the image rotating here in this little video, only then you can go to the next step. So the bottom of this, remember first we clicked on this generate button that created this little video. Now, from this AI generated model, we have to extract the mesh, the geometry that we can actually use in our 3D software such as DAZ Studio or Poser. So let's click on this little triangle here to open up the settings. We have two sliders. The first one, simplify, and the second one is texture size. We have a possibility of going 0.5K textures, 1K texture, and all the way up to 2K textures. So I'm going to, by default, use the 2K texture to make it as detailed as possible. Now, the simplify setting needs a little bit of explanation. What it's doing behind the scenes, it is generating the mesh at a certain higher resolution, and then it simplifies it, i.e. it takes away triangles or quads where it thinks you don't really need it. Now, the slider itself, if you put it at the highest value, that will result in a lowest number of triangles, i.e. lower quality mesh. If you move this slider all the way down to the bottom, to 0.9 that it's letting you, it will create the highest mesh density, i.e. the most number of triangles. Now, I found it a little bit limiting, this 0.99 just to 0.9. So, perhaps later, more advanced tutorial, I'm going to show you what you need to edit within this Trellis' source code so you can generate even higher density meshes. But that if you're inclined to play with some Python code and so forth, it's not that difficult. But for this tutorial, I want to keep it at the default, simplest settings, no changes. So I prefer to go down to what it allows me to 0.9 and crank up the texture size to 2K or 2048. Now at this point, then you're going to click on the extract GLB. And once you click that, you'll see that the little window below the animation is starting to do something, is doing some processing and so forth. So what it's doing is actually taking out and generating a mesh with a texture in a format that's called GLB. Now, the problem with this format is that I believe DAZ Studio for sure cannot use it, and probably Poser can't use it either. Don't quote me on that. But nevertheless, there are ways, relative simple ways, to move this GLB model, which combines the mesh, the triangulated geometry, and the textures within one file, to separate them out and save them out. In my case, I prefer the OBJ format, but probably FBX and other formats will work. All of those work in DAZ Studio. But you see, we're doing this in real time, so it took while I was yapping, maybe half a minute to generate the mesh. And this is a preview of the mesh. I'm moving it around. And now if I click on a button, I can save the GLB file. By default, I believe it goes into your download folder. So I've created one, and before trying to convert it, let's generate another model. Let's pick one that, for example, this one that's missing part of the horn. So it went through, I dragged it from the file explorer onto this image pane. I'm going to again click on the generate step. Upper right window goes blank. There is a very faint horizontal bar that's running across. I believe it tells you how far it's along. I don't know. But anyways, it shouldn't take that long. So once we have this little video playing, and note that even though the tip of the horn was cropped off, the AI model was able to figure out that it should continue and created the helmet. So that sort of tells you that if your image is not perfect, there is a chance that it's going to create a model that's usable. So it created that. Let's try to extract the GLB similar to the previous one. And again, it shouldn't take too long to do it. So the moral of the story is, if you want 10 models that you can use in DAZ Studio, start with 20 images that are meeting the criteria of almost perfect that you can generate in Stable Diffusion or whatever. So start with 20 images and do each and every within Trellis. And in the end, you'll probably end up with the number of models that you wanted. Not each and every will work. Some of them will require some 3D mesh editing in for example, Blender. But in this case, if you start with a larger number, you're going to end up with a decent number of models. So while this is doing its thing, at the end, I'm going to switch over to the directory where I have all these models generated, so we don't have to wait and look for this, and let's take a look at them of what we got prior to converting them into a format useful for DAZ Studio. So see you there in a moment. So welcome back after a second or two. So I've opened up the default location where Trellis is putting the models that it generates, and it calls them sample one, whatever. My idea is that I'm going to start with the file name of the image and rename each and every, so I can correlate back of what model came from what image. So I believe it was this one and that one with the cropped horns. So I'm going to name them accordingly, and then I'm going to take these two GLB files and put them into, just leave them there. So let's look at them briefly with Windows's 3D viewer right away. So let's see what we got. So let me zoom in. So this is the 3D model. Is it perfect? No. Is it useful? Absolutely. Is it worth the price you pay for it? Absolutely. So let's examine it briefly. So this is the GLB model containing both the geometry and texture. As it is, it might not be useful for our purposes in DAZ Studio. However, let's look at it, the issues, if there are any. Note that everything is there. It is hollow on the inside. So let me try to move this light. I'm not really proficient with this little program, but let's just look at it of what we have. We have this highlight, so it received the light from up here in that direction. It got some little side light. It has some highlights on the helmet, under the horn, somewhere back. So this is not ideal because chances are this may not correspond to the lighting that you want to set up your scene in your 3D rendering software, but this is what we got. Other than that, the geometry looks fairly complete. So now let's look at the other one, 3D viewer. And there it is. It has some extra geometry in it, which may or may not be in a way, but generally it looks complete, as we noted that the horns got fixed and so forth. So these are two useful models. Now, how do we go from this GLB model created by Trellis into something that's useful for us? So there are a couple of online resources that will be able to translate this model into FBX or OBJ. So let's try GLB to, let's see, OBJ file. See what we get. Convert your mesh, convert 3DP. I have no affiliation with any of these, and this is the first time I'm looking at it. So let's go with this 3DP if it's a viable alternative. So it tells me that I should be converting from GLB to OBJ. Upload your GLB file. I'm going to upload it. Let's pick the first one. Let's see if it's doing anything. So it uploaded. Okay, you can drag it around, and let's see if we can click on download, and it's apparently doing something. Probably transferring it, and now it lets me download it S, I believe. I guess it's a zipped file. So let's extract this file here, and we ended up in this case, and it seems like it worked without a hitch. Now, I cannot guarantee that each and every model will be this smooth. Again, there are various these online free converters. It is not my preferred method. However, for this tutorial, I find that it is something that you don't have to install extra software and relatively simple to do. So if it doesn't work if you generate your models and it doesn't work in one, you try another one. If it doesn't work in any of them, then perhaps later in an advanced tutorial, if there is interest for it, I'm going to show how to work with these models in another free software, 3D software called Blender. I believe a good number of you are familiar with it, but for the time being, let's just leave it as is. We take our GLB model from Trellis, we find a site that can claim to do this conversion, and we convert it, and we end up with, let's see what we end up with. So we started off with the GLB with a single file. We went through the conversion. We end up with two files: the actual geometry and the material description. Now, is this what we want? Is not necessarily what we want. Let's open up this material definition file, and it says that there should be an image file, and there isn't. So in this case, we do not have our texture, and that's a big problem. So perhaps this software was not, or online software was not suitable for what we wanted. Let's see if we have any way of downloading the image that it wanted. So I do not think so. So let's go back and let's try another one. Image to STL. So let's upload our file. We tried this one. Convert to OBJ. And let's see. Download as a zip file. We download it. It's downloaded. Extract all. Let's accept it. And note we have now, other than a README file, we have an extra file that is our texture map. So score for image to STL.com, and a big fail for 3DP, even though it sounded good. So let's look at it, what we have here. If I'm going to be right-clicking on the OBJ file itself and load it up into Windows as 3D viewer, there we are. We have our geometry and we have our texture. So at this point, there's absolutely nothing stopping us from take this and put it into DAZ Studio. So that would be the next stop in our journey to generate 3D models using this newfangled fancy thing called artificial intelligence that everybody says is our future until the AI thinks differently. Anyways, let's switch over to DAZ Studio and see what we get ultimately. So see you there in a moment. So here we are in DAZ Studio, and I'm going to import this OBJ file that we got from this online service that changed from GLB to OBJ. So I selected the files and at any arbitrary scale, and there it is with the texture. And let's examine it. Let's look at the geometry first. So I'm going to change it into perhaps hidden line. So you'll see that it is a triangulated mesh, so no quads. It is, in my professional opinion, a good quality mesh. it now. Let me move it up a little bit so we can peer inside of it from the bottom. The ground plane is not affecting our view. So you see that it has some interior elements that if you put it on a figure, it will, well, cut its head off. But, you know, it's not perfect. But I believe, you know, we'll try to put it onto a figure. So give it a moment. So let's see. Mesh looks good. Let's now switch over to Iray preview. Texture looks good as well. So is it something that's of high quality? Can you find better models at various marketplaces? Probably, yes. Would this model be something that I would be using in my renderings? Absolutely. Should you use it? Well, that's for you to decide. Given the amount of effort, cost, and well, whatever went into creating it, I believe at this point in time, and this is recorded in February 2025, we're pretty much at the threshold where AI 3D model generators can create geometry that can be very, very useful in your 3D renderings in DAZ Studio or Poser or any of these rendering programs. Would it be completely customizable at this point in time? No. We have to start off with either a textual description of what the object should be or an image. I believe by splitting up the mesh generation, model generation into two distinct phases of first generating an image, what we want, and then we feed that image into the 3D mesh generator Trellis. We have some control over what we feed in, if we're happy with it, and what we get out. So now let me load in a figure, and there we are. I loaded a Genesis 8 male figure. I made sure that it is PG-13 rated, and I've placed the helmet on top of his head. Now, note that you have absolutely zero control prior to bringing it into DAZ Studio about the size of this model. So whatever I imported it, at 100%, I had to scale it up by 3.5 times in order to get the fit that I think, again, I'm no expert in Viking helmets, but to some decent fit. So let's see how it looks like. If I kind of move around, let Iray preview rendering take over. Is it something you would use in your own modeling? I would, or own scenes, I would certainly do. Does it complement of what's available out there to buy? Absolutely. One thing that by this workflow, you create the image, pick the ones you want, you create the 3D model, and then you can have an absolutely tailor-made, let me render it out, an absolutely tailor-made model that fits into your scene with, given the limitations that I've listed, that the lighting is baked in. So if you finagle it a little bit, that you end up with an acceptable lighting situation for your scene that is in correspondence with the way these 3D generated models are lit, then it's a win-win situation. So I hope this relatively short tutorial gave you a little bit of insight of, in early 2025, what is out there as far as 3D mesh generator from two-dimensional images that you can, at this point, at a relatively low, relatively inexpensive entry point, you can incorporate in your workflow, and it's only your imagination is the limitation of what you can accomplish. So on that note, thank you for listening to my ramblings, and I hope that you'll be able to generate all sorts of interesting models. If you're interested in this kind of a content, please subscribe to my channel. I'm just starting out. I'm planning to have, on a relatively frequent basis, some kind of 3D AI modeling content, along the line of, say, I was thinking maybe some kind of Viking shields and a Viking village or something. I'm going to have all these models, at least a free model, or at least one free model available on my Patreon page. And if you think that your support is worthy of this cause, then you would be able to download every few weeks a pack that I make via this method, and you can download this on my Patreon page. Please see the link below. And I wish you all the best on your journey of 3D modeling and rendering. So see you next time.